This is actually the 6th edition of the Data Engineering Community, Demystifying Data Engineering series. And with Data Engineering Community, we're actually a community of beginner, experienced, and intermediate engineer. We actually provide a platform for anybody trying to pivot into the data space, especially data engineering. We have a collaborative WhatsApp group where we do a lot of insightful sessions, hold webinars, help people solve queries. So thank you for joining. And today's webinar is about building an impactful project. And we have Nancy on the call. Today, she will be sharing us how you can build an impactful data engineering project. She will be taking us taking us through the process of how a beginner can build a practical, ready to use MD portfolio that they can use to apply for jobs. She would be taking us through how we can achieve that, mistake to avoid, how to giving us tips on how we can have impactful project. So I'll just do a little bit of introduction about Nancy. I'm sure she would she would do the rest. So Nancy is somebody that I've actually been admiring in the data space. Permit me to call her woman leader. She is, if I'm correct, a 7 times Hackathon winner. I mean, when it comes to Hackathon, give it to Nancy. Hopefully very soon we'll win that $1 million Hackathon that that provides an impactful solution to the community. I mean, I always look forward to her and her journey. Um, Currently, Nasi works at MoneyPoint, one of the biggest financial sector in Nigeria. She currently as a data engineer, and I'm really excited to have her here to take us through this process. So yeah, I think I would just hand over to Nancy now and just let her get started through the process. Nancy?
Thank you. Can you hear me clearly?
Yes, I can, loud and clear.
Thank you for the introduction. Good evening, everybody. And it's really great to be here. I really hope that you are going to pick up some things from the one or two that I'm going to say today on this session. So I'm going to share my screen now so that I'll share my slides. Okay, can you see my screen? In full screen mode?
Yes.
Okay. Okay, so today I'll be discussing on how you can build impactful data engineering projects as a beginner. And the reason I chose this topic is because of, would I say, my background. I started in data when I was a student, 2022, data in general. I started as a data analyst. Because I was a student, I didn't have the opportunity to get a full-time job. It was going to be overwhelming for me balancing a full-time job and my studies. So I just went on with gigs, and that was when I transitioned into data engineering. So fortunately for me, when I graduated, few months after I graduated, I got a full-time job as a data engineer, not as a data analyst. So it might seem surprising to a lot of people, but it required a lot of work, and most of that work was based on the kind of projects that I built, and that impacted how I handled my interviews while I was interviewing for my first time data engineer job. So I'm going to enlighten you on how you can build impactful data engineering projects that can make your interviews much more better when you are discussing these projects with the interviewer. So going straight right into it. So why this matters for beginners like you, right? So first of all, it boosts your CV. And I remember while I was setting up my CV for apply for jobs, the only experience that I put there was the product management role that I had in a startup, an AI startup. And then all of that experience I put there was the projects that I'd worked on, as most of them were hackathon projects that I've worked on, right? So while you're a beginner and you don't have any experience, you can actually add projects that you've worked on to your CV to boost your CV. So yes, if you don't have any experience yet, adding projects to your CV can give you a chance. And then also it sets you up for success in your interviews. There's a difference between someone that has just worked on random projects that have no impact and somebody that have worked on a project that person deeply understands the impact that that project had, even though it might not be in real life or in the real world, but the person can somehow simulate the impact of that project in the real world. When you compare the way those two candidates talk in interviews, you will see that the latter, that's the person that understands or simulates the impact of that project in the real world, can be able to scale that interview. So the conversation between that person and the interviewer will be much more better than the other person, right? So it also sets you up for success in your interviews. And also, it's a win-win, right? It also helps you to improve your technical proficiency because you're always aiming for having the best projects and having projects that can have impact in the real world. Your technical proficiency is automatically improved. So on to the next. So what makes a data engineering project impactful? First of all, the number one let's say feature is that it should solve a real world problem. I think this was one of the, I won't say mistakes, I got to learn about it later on in my journey. I was more focused on just saying in this project I've used these tools, that was just what I was interested in. I just want to show that I can be able to use these tools in this project, but it goes beyond that, right? By the time you start interacting with interviewers in your interviews and they're asking you, okay, what problem were you trying to solve with this project, and you then realize that you did not really have any problem in mind, you just wanted to show that you can use this tool, that automatically disconnects you from the interviewer. So it's important for you to understand, or for you to build data engineering projects that solve real world problem. It's not, it's the users in the real world might not use your project, but you can simulate a real world problem and be able to solve that with a data engineering project. And then the next one would be business driven. Business driven in the sense that you need to be able to understand what impact that project can have on a business. It might be similar to solving a real world problem, but there's a slight difference. Now, when you have solved a real world problem, yes, in your project, but then when you are not driving a business decision, you are now making, let's say, you are now having that trying to show that you are thinking about the business. Yet, because anybody that wants to take you in as their employee is for their business, for you to improve their business or cut costs. So you also should be mindful of the business too, right? So that's being business driven. Yeah, whether you're trying to cut costs or whether you're trying to save time. And that brings us to measurable outcomes, the next feature. So I know this might be hard, especially since you're not doing this in the real world. But then you can be able to, there was something I learned when I worked on the last data platform engineering project hosted by Mr. Mayowa and Mr. Najib, right? So there was one question that one of the guests on that meeting kept asking about how we were sure that the solution we used was more cost affordable compared to other solutions. That gave me an idea of, okay, if in a case where someone was building a project and they have different solutions for that problem, and then they compare the impact of those different solutions in terms of maybe how much time it saves or how much money it saves. If one can do a project like that and then show that, okay, it's better to choose solution A than solution B because the amount of dollars it saves that solution A saves compared to solution B is so and so. You can even show a screenshot on that. Now, that kind of outcome that you've measured alone gives someone that is reviewing that your project a kind of hint that, okay, this person is not just even trying to solve problem. This person is also going deeper into understanding that businesses want to also save time and save money with this with any project that they are going to work on, and that even increases your chances of landing the role eventually if you are discussing this with someone on an interview. So having these three major features, right, it helps you to make your data engineering project very impactful. Now, what does a typical data engineering project overview look like? I know that it's hard for some people have met me about how they cannot know the kind of project to work on. They don't understand what they need to do. So this is more like an overview, right? I used the typical data engineering life cycle as a project interview. So first of all, data ingestion is very important. In the real world, you are trying to move data from one point to another, most likely transactional databases, APIs. You're trying to move this into the OLAP databases so that the data consumers, that's data analysts, data scientists, can be able to use them. So data ingestion in a data engineering project is very important. And then the next is data transformation, because as data engineers, they call us data plumbers, where we have to transform the data that we ingested so it can be usable for the data consumers. So data transformation too should be involved in your data engineering projects. Then data storage, right? You need to store this data that needs to be accessed by these data consumers eventually. So data storage. And then pipeline orchestration. In the real world, there's a noise in the background that is distracting. Okay, so in the real world, it's important for you to also automate whatever you build. Most times we are building systems that helps in ingesting data, transforming this data and storing it, right? But it's also important to automate it, and that's where pipeline orchestration comes in, where you need to establish dependencies between tasks, make sure that it's scalable, and make sure that if you want this to run by 8 a.m. daily, that pipeline should run 8 a.m. daily, right? So this is where pipeline orchestration comes in. Then data serving, I would say this is optional, although in most of the projects I've worked on, I feel like sometimes there might be the need to show people how your data, how the data that you say you've cleaned looks like. So you must not even know how to build dashboards. This is where collaboration even comes in, where you can collaborate with other data scientists that can build machine learning models on top of the data that you've transformed and stored, or data analysts that can build dashboards on top of the data that you've transformed and stored, right? So you must not necessarily build these dashboards or build machine learning models by yourself. This is where collaboration comes in. Then the sixth one is data infrastructure management. This is where you see people that are interested in data platform engineering, where they are also trying to manage the data infrastructure. So this is where you see people that are more involved in, okay, what AWS services to use, what services to use, what open source tools to use, how they can set up these tools. So this is actually important, because I mean, the tools that you are even going to use in the first place, they are not something that they are not already set up for you. You have to set it yourself, right? So this is also important. Data infrastructure management is also important. So on to the next. So steps to build an impactful project. First of all, identify the problem. Don't start with, okay, I want to work on a project that involves Airbytes and DBT. Which project? Where will I get data? I think that's where most people start from. I want to work on a project that involves these tools. Where can I get this data? But you shouldn't start from there, right? Even when I started as a data analyst, there was this thing that I usually do. First of all, I think of the industry that I want to build a project on. If it's e-commerce, if it's finance, I think of that. And then I go online and search for something like business problems that data can solve in that industry. So business problems that data can solve in e-commerce, business problems that data can solve in finance industry. So when I search for things like that, you start seeing the different problems, analytical problems, data engineering project. So most times you even see just analytical problems, but as a data engineer, you can think backward and get some inspiration on the data engineering projects to build that can empower that analytical solution, right? So you need to identify the problem first. That even makes it more motivating for you to work on a project. Then the next thing, after you identify the problem, you choose your data set. I understand that this is also challenging for some people where you hardly see data sets, but there's usually Kaggle. There is this database that might be popular, AdventureWorks. I think that one is the one that simulates a real world problem. So you can check that out. So AdventureWorks database. There are several places to get data sets, right? There is even some APIs that you can get data sets. If you're working in the finance industry, there are APIs like Y Finance that you can get data from. So when you get this data, the next thing is to design your pipeline architecture, not just going straight to start building. You have to design your pipeline architecture. Now, while you are designing your pipeline architecture, you are doing some research on why you are choosing these tools instead of these other tools. So why are you choosing Airbyte instead of a service on AWS that still does the same thing that Airbyte does, right? So while you are doing this, designing this pipeline architecture, you are doing further research on why you are choosing those tools. This helps you because when you are now documenting, you get to state the reason you chose those tools that you used, not just for using sake. This also helps you because in a case where you eventually get a role where you are the solo data team, then you have to like handle things on your own, and that's where you start seeing the need for you to know why you should choose this tool and not this tool. So designing the pipeline architecture is very, very important. That also helps you to know the steps that you take in building your data engineering projects too. So when this pipeline architecture is ready and the reason you chose each of those tools in the architecture is ready, the next thing for you to do is to then implement the architecture. That is, you start building your project. So you are building your project, you're looking at your architecture, you're following it. And when you are done, the next thing is to measure impact. Remember where I mentioned about comparing two solutions and seeing which one saves more money or saves time. You can do something like that. You can even have two pipeline architecture, see which one you can, when you implement both of them, you compare their impact. You then, in your documentation, you then state the one that solves the problem better. They might solve the problem, but you then state the one that has more impact in terms of how much money it saves or how much time it saves, right? So just try to measure that impact. Then the last one is to document it comprehensively. While this might seem like something simple for some people, it's not for a lot of people. I understand that as data engineers, sometimes it can be hard for us to write, but then it's also important for you to put out what you've built so that other people can understand what you've built, right? Because like coming back to the aim of this session for beginners, right? As a beginner, you've not landed your first role yet, or you are trying to pivot into your first data engineer role. Now, when you document all your projects well, and then you link your projects in your CV, when the interviewer is going through these projects, they would be wild because they are seeing somebody that understands what they are doing. It will be different from going through other people's projects that don't even have any documentation, that is just code that food the whole GitHub and that's it's no readme, right? So it's important for you to document it comprehensively. And then a bonus point is for you to observe best practices. It might be difficult at first, at your first few projects, but as time goes on, you will start observing best practices like using, for example, in terms of Python, implementing modularity in your code, ensuring that you have detailed comments. Each functions that you have in your code should have details on them to show what each function is being used for, and then having a good project structure on your GitHub, mostly GitHub or GitLab, right? Having a good project structure on that. So those are some basic best practices. You can research further on best practices that you can implement on projects. So now, mistakes that you should avoid. Focusing so much on tools instead of solving problems. I'll still say that this is one of the most common mistakes people make. And this is also one of the mistakes I made at the earlier start of my career. I still remember a particular project where I worked on that was related to Spark. And the only reason I did that project was because I wanted to show that I know how to use Spark. That was the only reason. So now that I think of it, it didn't really make sense. But yes, we learn from our mistakes. So don't make mistakes like that, because when you eventually get to interviews and they ask you, okay, why did you do this? Why did you use this instead of this? You are then wondering what to say because you don't really know why you use that instead of that. You are more focused on the tools instead of solving problems. So the second one is keeping documentation. Don't do this mistake. When you push out your code and say, I've worked on a project, this is a project I've worked on, you can access my code on this GitHub repo, and they open your repo and there is no README on what they should expect on your project. That just puts people off. Just aside interviewers, it puts people off because nobody wants to start digging into your code when they don't understand what your code is expected to do, right? So don't try to skip documentation. And then 3, ignoring scalability, performance, and best practices. There is one common thing I notice in some projects I've seen, and that's in the part of most projects having Jupyter notebooks. Jupyter notebooks, I see Jupyter notebooks as more for development, where you are trying to see what your data is giving you while you are transforming your data or ingesting your data from somewhere. But if you think of deployment, you cannot deploy Jupyter notebook, right? You need to have convert it to a .py file for it to work properly. So in cases like that, if you are still having Jupyter notebooks, it can actually put some people off that this person is not even thinking of cases of deployment for this project. So that's one thing you should take note of. And then the best practices that I also talked about, don't ignore it. It can be hard when you are trying to implement best practices, especially at the earlier stage of your career. But as time goes on, you'll be able to do that and seamlessly. So the most important thing is that you are trying to do these things. You are not just ignoring the fact that these things exist. And then the last one is not getting feedback before making it public. It's good that we already have some experts in the data engineering community that you can always reach out to to help you to look at your projects. I did not have that at the beginning of my career where I had people to rely on to look at my projects. But as time went on, as I joined the data engineering community, I had some people that I could always reach out to ask to review my projects. You already have a community like this. All of us are from this community. So don't be one of the people that are rushing to post a project. People that will say, I have cooked, when you have not really cooked anything, right? It's important for you to go to experts that you are aware of. Tell them, please, can you spare some time to look at this project and see if there is anything I could have done better. So get feedback before you make it public. Now, how to showcase your projects? GitHub, the top place. Anyone that asks me, I want to be a data engineer, how can I showcase my projects? I always say GitHub, right? Have a good folder structure for your code and ensure that your README is comprehensive. Then the next one is blog posts. Blog posts, I see it as more of going deeper into what your project is about. So at some point when I do some projects, I usually have both GitHub repo. There on my README, I still have a documentation of my project and some sections, right? And then my blog post is now what is going to allow me to tell all the grammar and the story that I want to tell about this project. So blog post is very important in helping you to showcase your project. Well, that's if you're like me that likes saying stories. But if not, then maybe you could stick to GitHub and ensure that your README is comprehensive. Then another place is your LinkedIn or your personal website portfolio. In LinkedIn, I have some projects that I attach to, I think, my project section on LinkedIn, just in case anybody is viewing my LinkedIn profile and they see some projects I've worked on. So you can do something like that where you organize your project on the LinkedIn project section, or you can have a personal website that you showcase all your projects. When I was trying to pitch myself as data analyst, I had a personal website portfolio that someone built for me. So that was what I usually attached to my CV. So you can also have something like that to showcase all your data engineering projects too. So if you have any of these three, then you are good to go. Thank you very much for listening. So I would say you should pause on asking your questions yet. What I want to do now is to review some projects that we are submitted on the form. So there were only 2 projects. I'm actually going to review only one because one did not have a documentation. So I'm not sure there's any need for us to go into that. So the first one I'm going to review is this one. So this is from Richmond. Please, can you still confirm that you can hear me?
Yes, I can, Nancy.
Okay.
We can hear you.
So, okay. So this is a project from Richmond, and it's really good to see that he had a README that describes his project and what he wanted to work on, right? Or what he worked on, rather. So looking at this, first of all, one thing is missing: a problem statement. This already highlights, this place already highlights the fact of these two already highlights the part of being more interested in working on projects because of you want to use those tools rather than solving real world problems. So if he really wanted to solve a real world problem, then he should have added that in the documentation. So problem statement is very important when you're trying to document your project. And then it's good that he also listed these skills that's the tools that he used on the project. And he mentioned the data set, although he didn't link it here. I'm guessing maybe that was a mistake. And then there were questions. This seems more like let's say, data analysis project than a data engineering project. Although I'm guessing maybe what he wanted to do was he did the ingestion and the transformation, and then he wanted to have the questions to answer on his README. But one important thing that he also missed is why he used these tools and not another set of tools. So why did he choose to use Redshift and not maybe just a normal database to query the data? Yes, you are trying to depict OLAP, but there should be a reason why you're going for something as big as Redshift rather than a simple database. Same thing as the S3. So why did he choose to use S3 and not another tool for storing the data? So it's important for you to highlight the reasons why you're choosing these tools to use. Another thing that is also missing is how these projects can be set up on someone else's environment. Sometimes someone will want to see, okay, this code that this person has, is everything correct? I want to see. But then there's no way on how he can start setting up this project on the local environment for someone to be able to test and see, okay, is everything fine here, right? So it's important for you to also show how someone can set up this project on their own environment. Then something that I mentioned on while talking was this, right? So everything is a Jupyter notebook. Like I said, this can put some people off because they'll be like, this person is not even thinking in the aspect of deploying this project. So you should also mind this is important. I've seen cases where people talk about how anybody that is still using Jupyter Notebook, that person is, especially data scientists, that person is have not worked on any product, any machine learning model on production, blah blah blah, all that might be some kind of mockery, but there's a little truth in that. You need to understand that it's important for you to think of deployment too when you're working on projects like this. And then another thing that is missing too is a good project structure. There is no folder to hold this, no folder for me. Of course, the files are named ingestion, pipeline. I'm guessing this is for automation or transformation, but then it's good to have folders that explicitly states this folder ingestion, this folder transformation, this folder orchestration, things like that, so that someone can know, okay, I need to go inside this folder to see what I need as regards transformation. So this is like a brief on this project review. What I'm going to do now is I'm going to review one or two of my projects to show you at least good examples of how your project should be, right? So this first one is actually most of my projects are hackathons. I only build projects for hackathons. That's where I get inspired to build real world projects, right? So I'm going to review this. So this first one is an invoice tracker tool. And first of all, I included the architecture. Normally, I don't really include architecture at the very top. There was a reason for this. But then still I included an architecture for this. And then I started with a problem, right? I like making my problem to look like somebody's talking. So that's why it's like this. So you have a problem in your documentation. Then the solution. The solution then involves the tools or the solution then involves what should be expected. How will my solution solve that problem that I've already stated? So that's the solution. And then these prerequisites, this is more of what someone that wants to set up this project on their environment, what that person should have on their laptop or on cloud if they want to set it up on cloud. So this is prerequisites. And then this is how they can set up their environment. Then I also I made a blog about this where they can click here and go into the project in details. And that also contains screenshots of the project. So now in this I added, you notice how somewhat descriptive the folders are. There is the connectors, this involves setting connectors, this Google Drive and MongoDB. So this is where they can find the connectors. These images is just where I store the images that I linked in this README. And then this UNS MCP, this is where the code on the MCP server is. So this is like say a structured project folder for this, and this is how the README is. I did not want to make the README so detailed because I already had a blog post that detailed the project folder. But then what I made sure that I did not miss was the problem, the solution, and how they can actually set up this project, how someone else can actually set up this project on their environment. Now I'm going to also review this one. I feel like this one was more detailed for me. So this is another project that I worked on, right, alongside somebody else. And then I had a problem statement again. And then I added why this problem or why the solution that we have is important to the education industry. So now if somebody reviews something like this, and maybe it's even an edtech company that is trying to employ me as a data engineer, they'll see that, okay, I already have a kind of enlightenment on how to solve problems for edtech companies, right? So this was also important for me to add. And then there is the solution approach. So here I added what each of the tools I'm using for each section, what they are for. And then I now included the reason why I chose those tools, or why we chose those tools. So these are the reasons we chose those tools to use. And then there's the pipeline architecture for this. Then we went deeper into breaking down each of the sections. That's the data gathering. We even added the ERD diagram for the tables in the transactional database we intended to ingest from. Then for the cases where we are getting it from APIs, we added some information about the API. Then for the data ingestion, we added a screenshot of how we did it in Airbytes, and then some other screenshots. And then for data storage, we added some information on how it's stored on MotherDoc. And then for data preparation and modeling, we added some things that we did while modeling and transforming the data. Then for the machine learning part, we added some information on that. Remember, I mentioned that you might choose to collaborate with other people. If you don't want to work on machine learning or visualization by yourself, you can collaborate with other people too. So this was what I did here. It was not me that worked on this machine learning part, was my colleague. And then the reporting and visualization. Yes, I did this because I have a bit of visualization skills. So I wrote about that and did that. Then the pipeline orchestration, I also mentioned that. Now at the end, I then mentioned the value that was generated. Why there were no numbers like, okay, this is the amount of dollars I saved, or this is the amount of time that I saved. I still kind of tries to show some value that this solution can bring while solving the problem that was stated at the beginning. And that was it. Now going back to the project folder, you will see how descriptive it was. There is a part for the machine learning. Then there's a part for the Streamlit that has the visualization, where we did the visualization. And then there's the images. These images is what we linked in the README. And then there's the Darkstar MLDBT, that is the code that has the Darkstar code that was used for the machine learning model orchestration. That's in terms of deployment, MLOps. Yeah. So this is where the code is. Then these APIs, these APIs was actually made by us. So this is where we also had the code for that. And then the workflows, these GitHub workflows, this is okay. This GitHub workflows, this is where the deployment of this solution into the Darkstack cloud, this is where the code was. Then there's git ignore readme, this is the Darkstack cloud.yaml, and then there's the requirements.txt. So you see how structured it is, where you know that, okay, I'm just interested in machine learning code, the person is coming here. I'm only interested in Darkstack code, the person is coming here. How did the person make this API? The person is coming here. Okay, how did the person make this visualization on Streamlit? The person is coming here. So you're kind of guiding somebody on how to actually explore your project without you coming on a call with that person to say, okay, this is where you need to click and this is where you need to click. So trying to understand this, putting yourself in the shoes of the people that is going to review your project or view your project away from you when you push it out in public, while they are building your project, you need to also consider things like that while you're also documenting. That will help. The thing is, somebody can build heaven and earth, but if the person did not document that project properly, then that person's work is rubbished because nobody will understand the heaven that that person built. So you need to make them understand the heaven that you've built by documenting it comprehensively. That way, when you're adding it to your CV, you have no fear that this interviewer might not understand my project. Instead, the interviewer will be very impressed and they might reach out to you for an interview. And when they decide to talk to you about it, you are very courageous and bold on the decisions that you made while you are working on that project. So it's a win-win eventually. And I hope this session was impactful for you in understanding how you can build impactful data engineering projects, even as a beginner. Thank you. I'll be taking any questions now.
Thank you so much, Nancy. That was really an insightful one. Thank you for sharing this with us, because even myself, I can see one or two mistakes that I need to work on. This is really nice.